for what values of x does the series, it's going to be n equals 0 to infinity, x to the n over n factorial, converge. So this is kind of similar to our last one, our very first one, except the factorial's in the denominator, not in the numerator. Okay. Okay, so with all of these power series, I said you automatically go to the ratio test. That's going to be the one test that's most frequently used now. Okay, so I'm going to compute the limit as n goes to infinity. Plug in n plus 1 everywhere. And then divide by an, which is this term here. And then I'm going to flip it when I bring it up. So n factorial over x to the n. So move around your terms to make the like things, put them together. So I'm going to just shuffle the terms in the denominator. I'm going to put x to the n first. Okay. So I want to simplify. X to the n plus 1 over x to the n simplifies to x. You just subtract the powers. And then here we simplify like we did before. You write n plus 1 factorial as n plus 1 times n factorial, and now the factorials will cancel. So you're left with x times 1 over n plus 1. One over n plus 1 is positive, so I can bring it outside of the absolute value. And then x could be negative, so I've got to leave it inside of the absolute value. I pull it out in front just like before. The absolute value of x, 1 over n plus 1. 0. The limit is 0. The numerator is 1. The denominator gets big, so it doesn't matter what x is, because this limit is 0, means I'm always going to get 0 for this limit. What does the ratio test tell me when I get a limit of 0? It breaks down if it's less than 1. It's absolutely convergent, so it converges. If it's bigger than 1, it diverges. If it's equal to 1, it's inconclusive. So here I got 0, which is always less than 1. So what we just found out is no matter what value of x we pick, this limit's always going to be less than 1. That means the series is always going to converge. Okay? So this series always converges by the ratio test. So one way you could say that is it converges for all values of x. Or if you wanted to do an interval like we did in the last example, what would my interval be? At every single value, it converges. Negative infinity to infinity, all real numbers. Okay.
So we have, so we just looked at the x to the n part and noticed that it's centered about 0.
It was centered about 0, so we know it converges at 0, but the question is, does it converge for any other value? You always know it converges for at least one value, but I want to find all values where it converges. It's kind of like, like our statements before about geometric series and p-series. What's nice about those statements is that I know when they converge and diverge, right? If my value of r, the absolute value of r is less than or equal to 1, if there's a condition on p for a p-series, and so you're always saying when that series converges, there's just a general rule. And that's kind of what we're doing here for these particular examples, is we're trying to create a general rule. If you have this series, I know it converges provided this happens, provided x is in this interval, or x is this value.